Welcome to today's tutorial on inheritance in C++. Inheritance is a crucial concept in C++ and object-oriented programming. It allows us to create new classes based on existing classes, extending and reusing their functionality. This powerful mechanism promotes code reusability and enhances the overall design of our programs. Inheritance can be defined as the process by which a class derives properties and behaviors from another class. The class that serves as the foundation is called the base class, while the class that inherits from the base class is known as the derived class. Consider a real estate agency that deals with different types of properties, such as houses, apartments, and commercial buildings. To manage these properties efficiently, the agency could use inheritance. In this scenario, we can define a base class called property that contains common attributes and behaviors shared by all types of properties, such as address, price, and number of rooms. This base class represents the general characteristics of a property. Now, we can create derived classes for specific types of properties, such as house, apartment, and commercial building. These derived classes inherit the attributes and behaviors of the base class, property, while also having their own unique properties. In C++, inheritance is declared using the class keyword, followed by a colon and the access specifier, and then the name of the base class. The access specifier can be one of three options: public, protected, or private. By default, if no access specifier is provided, it is considered private. C++ supports various types of inheritance, each serving a specific purpose. Let's explore the most commonly used ones. First is single inheritance. It is the simplest form of inheritance, where a derived class inherits from a single base class. The derived class extends the functionality of the base class by adding new members or modifying existing ones. In the above example, we have a base class shape that contains two protected member variables width and height, and two member functions set width and set height to set the values of these variables. The derived class rectangle is created using single inheritance by specifying public shape. This means that the rectangle class inherits the members of the shape class and can access the protected members of the base class. In the main function, we create an object of the rectangle class called rect. We then use the inherited member functions set width and set height to set the values of width and height respectively. Finally, we call the derived class member function getArea to calculate the area of the rectangle. Next, multiple inheritance. It allows a derived class to inherit from multiple base classes. This means that the derived class can access members from all the base classes. Let's see C++ example. We define two base classes, base class 1 and base class 2, each having a member function display1 and display2, respectively. We then define a derived class, which inherits from both base class 1 and base class 2. This is achieved by using multiple inheritance, denoted by a comma-separated list of base classes. The derived class also has its own member function, displayDerived. In the main function, we create an object of the derived class. We can now access the member functions of base class 1, base class 2, and derived class using the object obj. Here, obj display1 calls display1 from base class 1, obj display2 calls display2 from base class 2, and obj display derived calls display derived from derived class. Next type is multi-level inheritance. It involves a chain of inheritance, where a derived class inherits from another derived class. This forms a hierarchical structure, allowing the derived class to access members from all the intermediate base classes. In this example, we have a base class called animal, which has a member function each. The first derived class is dog, which inherits from the animal class. It adds a new member function bark. Finally, we have the second derived class Labrador, which inherits from the dog class and adds its own member function display. In the main function, we create an object of the Labrador class called Labrador. We can observe the multi-level inheritance in action by calling various member functions. Labrador.eat invokes the eat function inherited from the animal class. Labrador bark invokes the bark function inherited from the dog class. Labrador display calls the display function defined in the Labrador class. Next, hierarchical inheritance. It occurs when multiple derived classes inherit from a single base class. This forms a tree-like structure, where the base class acts as the common ancestor for all derived classes. In the given example, we have a base class animal and two derived classes dog and cat. Both dog and cat inherit from the base class animal, forming a hierarchical inheritance structure. The animal class has a method eat, which prints, animal is eating. This method is accessible to both dog and cat classes as they inherit from the animal class. The dog class has an additional method bark, which prints, dog is barking. Similarly, the cat class has a method meow, which prints, cat is meowing. These methods are specific to their respective derived classes. In the main function, we create objects of the dog and cat classes. We can then access the eat method of the base class through the derived class objects. Additionally, we can access the bark method of the dog class and the meow method of the cat class. That brings us to the end of our tutorial on inheritance in C++. If you have any questions, please feel free to leave them in the comments section below. Thanks for watching. Please subscribe the channel.